Okay, energy balance of closed system. Okay, E in minus E out equals to delta E system. So, E in is actually equals to Q in minus Q out. Okay. Q in. Okay, it is total of, energy is total of Q plus work. Okay, we will discuss about this later, how the equation goes from here into here, okay? But when we rearrange the equation, we will get this Q in minus Q out plus work in minus work out. It is also equal to delta E system. Okay. Okay, so for closed system, there are no mass being transferred in or out, okay? But the energy can be transferred in or out, okay? The work boundary done on an adiabatic system is equal to the increase in the energy of the system. So if you supply 10 kilojoule, the changes of energy is equal to 10 kilojoule. The energy change of a system during a process is equal to the net work and heat transfer between the system and its surrounding, okay? You need to consider everything, the work and the Q. So Q being supplied is 15 kilojoule. So it is Q in. Q out is 3 kilojoule. But work in equals to 6 kilojoule. Okay. So based on this, based on this equation, so you have Q in 15. Q in is 15. Q out is 3 kilojoule. So delta Q is actually equals to 12 kilojoule. Okay. We do have work in, okay, work has been supplied, okay, work done on to system, okay, but we don't have work out, right? Therefore, work out is equal to 0. So work in 6 minus 0. So that's why we have this equation. So this one is coming from here, okay. So 15 minus 3 plus 6 equals to 18 kilojoule, okay. Okay, so Q, okay, we just simplified the way we writing and the way we write the energy balance, okay. Q for Q net in, so it actually is Q net in. So our subject is Q net in, so we just put as Q only, which is equal to Q in minus Q out. But for work net out, okay, for work it is represented by net out. Therefore, so this is the subject is about net out. Therefore, work out is the we put it at the first equation. Work out minus work in. So by using this equation, so you put it at here. Okay. Okay. So Q net in minus work net out. So just now it is right, Q in minus Q out. So this is Q net. Okay, this one is plus, right? But since our work net, we start with work out minus work in. Therefore, this one is going to be negative. That's why we have this. Okay, Q net in minus work net out. So initially, it is delta Q, right? Q in minus Q out plus work in minus work out. But because we put the work net out as your subject at here and the equation is work out minus work in, therefore, we need to put negative at here. Okay? So, Q net in minus work net out equals to delta E system, or just simplify the equation but we just write it down as Q minus work equals to delta E. This is important for you to understand. How do you relate with the original equations? Okay? So, energy balance when sign convention is used. Example, heat input and work output are positive. Remember this one? We have discussed about this in earlier module. Okay, a previous module. But the Q out and work in is negative. This is important to be considered. So generally, Q minus work is equal to delta E. Okay, but for stationary system, Q minus work equals to delta U because delta KE and delta potential energy is equal to 0. Therefore, we only have this. Okay. But this one is for unit mass. Therefore, it is for specific. Remember, Q over the mass. Okay. We have a small letter of Q, small letter of work, and small letter of, this is total E, delta E over mass. So, we get delta E. Okay, differential form, this is the symbol. It's just in term of different condition. Okay, in this case, for a cycle, delta E is equal to 0. For a cycle, delta E is equal to 0. Therefore, Q equals to work. So, if this one is delta E equals to Q minus work. Okay, so if delta E equal to 0, Q equals to work, because it is in a cycle. Okay, so the first law cannot be proven mathematically, but no process in nature is known to have violated the first law, and this should be taken as sufficient proof. Okay.